Not 9.4, my bad. It's 9.5. Yeah, we will skip 9.4 instead. Binomial Theorem. What we will learn here, we will learn the expansion of a plus b to the n. That's what we learn. Let's see what we have had so far. Let's see, for example, we have known that a plus b to the 1, of course, is equal to simply a plus b, right? And then we also have known a plus b squared equals to a squared plus 2ab plus b squared. Now, of course, the simplest one is a plus b to the 0, then that's simply 1. Right? Now, let's extend this further. Let's extend this further. Suppose we would like to see some pattern first. Okay, we like to see some pattern, and then we develop that further and further, and even to the more general case. Now, how about a plus b to the power of 3? A plus b to the power of 3, let me call this a new example. This will be a plus b squared times a plus b, which is a squared plus 2ab plus b squared times a plus b. And then from here we FOIL it. Okay, from here we FOIL it. That will be, let me distribute the a first, a cubed plus 2a squared b plus ab squared. That's if I distribute the a. Okay, and then when I distribute the b, I get a squared b plus 2ab squared plus b cubed. That's if I distribute the b. Now then, combining like terms, that gives me a cube plus 3a squared b plus 3ab squared plus b cubed. Okay. Now from here, I can do one more. I can go to a plus b to the 4th further if you want me to. But I guess from here, I will just go ahead to the pattern. We will see the following pattern. The pattern is the following, that first one, the number of terms is equal to n plus 1. So you see when the n is 0, we have one term. When n is 1, we have 2 terms. When n is 2, we have 3 terms. When n is 3, we have 4 terms. Right? Okay. So the number of terms equals to the exponent plus 1 terms. Okay, second, the degree, I think I should say the total degree of each term is equal to n. As you see that here, the degree of n is 3 here. Notice that for this term, the degree is 3. For this term, the degree also 3. 2 from A, 1 from B. For this term, the degree also 3. 1 from A, 2 from B. And for the last term here, the degree also 3. Okay, for squared, for example, for A plus B squared, the first term is A squared. The second term is AB, which is the degree of 2, if we combine them, right? And then B squared. So if n equals to 2, then the total degree for each term, I'm supposed to just say the degree for each term. But to emphasize, the total degree for each term is n. Okay. The third thing is the third pattern is that the degree of A starts from n down to the degree of 0. Okay, if we put them in order, right? So if this is the degree of 3, the first term being expanded, it will be a cubed, a squared, a, and no a to the 0, right? Okay, and the degree of b, the second term in the binomial grouping, the degree starts from 0 to n instead. Notice that the total degree has to be n, right? So the first term, the total degree is n, comes from a to the n, b to the 0, while the last term is a to the 0, b to the n. Is it okay? And then I think the following is not really important, but nice to know that the first term and last term, sorry, nothing, the last term, has coefficient 1, has coefficient 1. In fact, we can say more that the second and second from the last have coefficient n. Now, for now, I need you to memorize this. Toward later on, we have more and more to memorize, but I think these four things here is quite easy to memorize. So for example, if I want to do this expansion here, suppose I want to do the expansion of a plus b, let's say to the 7th. Then there should be 8 terms. Okay, 8 terms. We start from a to the 7th all the way to b to the 7th. Okay, let's put it out for now. This will be a to the 7th, plus, notice that this is the degree of n, right? Okay, so the second term will be n a to the 6b. Okay, now the third term, we don't know the coefficient yet, but we know it will be a to the 5th b squared. Notice that the total exponent is still 7, right? The total exponent is still 7. Plus something a to the 4th b cubed plus something a cubed b to the 4th plus something a squared b to the 5th plus something a b to the 6th plus b to the 7th. Oh, you know what? We actually know this thing. What should this be? Yeah, the second term and second from the last, the coefficient is n. Okay, so this is the first things we need to know, that if we have degree of n, if I have degree of n, in this case degree 7, then I should have eight terms. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms. Okay, and the first term a has degree start from degree of 7 and all the way down degree of 6, 5, 4, 3, 2, 1, no 8. Okay, and degree of b on the other hand is increasing. Okay, from degree of 0, b to the 1, b squared, b cubed, b to the 4, b to the 5, b to the 6, b to the 7. The first term and the last term has coefficient 1. So we have coefficient 1 here, coefficient 1 here, the first term and the last term. The second term and the second from the last term has coefficient n. Okay? Now, of course, our next challenge is then how to find this thing here, the coefficients here. Okay, how to find the coefficients. Actually, in the process that I will show you, we will also find the coefficients, actually the coefficients for all of them. Okay, now there are 2 methods to do that. There are 2 methods to find the coefficients. Here, 2 methods. To find the coefficients. The first one is we can use Pascal triangle. They call that Pascal triangle, but as I know, according to history, plenty of people already know this fact. You can see this Pascal triangle on page 677 in our textbook. It's basically as the following. Yeah, it's basically as the following. We start from 1 in the first row. The second row, 1, 1. Now then, on the next row, we start from 1, and then the next term comes from the sum of these 2, and then 1. Now, and then the next row, it will be 1. The sum of these 2 gives me 3 here. The sum of these 2 gives me 3. And then we end it with 1 again. And then 1, 4, 6, 4, like that. Okay, now what does this triangle representing? Now the first one here represents the coefficient of a plus b to the 0, which is simply 1. Okay, now, while this one here represents the coefficient of a plus b to the 1. So that's a plus b, whose coefficients are 1 and 1. The next row, 1 to 1, represent the coefficients for ab squared. That's a squared plus 2ab plus b squared. Notice that the coefficients 1 to 1 for this 1, and then 2, and then 1. Okay. Remember we did that a plus b cubed upstairs? Okay. When we did that a plus b cubed, we see that it will be a cube plus 3a squared b plus 3ab squared plus b to the third. Okay, where this 1, 3, 3, 1 here appears at 1, 3, 3, 1. Okay, now suppose we have not done this. We have not done this? We have not done the expansion for a plus b to the 4. But we have the coefficients already. And we also know there should be, because the n equals to 4, there should be 5 terms, starting from a to the 4 all the way down to b to the 4. Okay, so it will be a to the 4 plus 4a cubed b. So my a to the 4 has coefficient 1. A cubed b has coefficient 4. And then plus 6a squared b squared. The coefficient 6 comes from here. And then coefficient 4 coming next. That's plus 4ab cubed. And finally, coefficient 1b to the 4. Okay, so right now we are at degree 4, right? Now, if you want to go back to example 2, and you want to find the rest of the coefficients here, what you can do, of course, is to extend it to 7. This is degree 4, and then you go on 1, 5, 10, 10, 5, 1. This is degree of 5, degree of 6, 1, 6, 15, 20, 15, 6, 1. Now let me know if I'm too fast. This 6 comes from the sum of these two, 15 from the sum of these two, the sum of these two, the sum of these two. So for degree of 7, that will be 1, 7, 21, 35, 35, 21, 7, 1. Okay. One important thing to observe is that the sequence, the order of those numbers, of those coefficients, if you read it from left to right, is the same too if you read it from right to left. Okay, so the coefficients will be the same if you read it, will be symmetric basically. Okay, it will be symmetric from the left-hand side and from the right-hand side. Now, with this said, then this coefficient 1 for this, coefficient 7 for this. The next one is 21 and then 35. So this is 21, 35. And notice that it's symmetric, right? From the back also 1, 7, 21 from the right, and then 35 from the right. Okay, Let me not filling that up there because if you look at the notes, uh, I don't use the later portion to answer the previous portion. So let me just do it underneath. Let me do this underneath. Then using blue, then this will be a to the 7. A plus b to the 7 is a to the 7 plus 7a to the 6b plus 21a to the 50 squared plus 35a to the 4b cubed plus 35a cubed b to the 4 plus 21a squared b to the 5th plus 7ab to the 6th plus b to the 7th. Okay, now we use this Pascal triangle method usually when, especially when when n is small. Even though I have to admit it's quite relative what is small in this case. Okay, but I'm trying to anticipate what happens if n equals to 12. Notice that this Pascal triangle is a triangle that is built recursively. What do you mean to be recursively, Thomas? It means for us to build the degree of 7, I need to get degree of 6 expansion first. And to get the degree of 6 expansion, I need to get the 5th one, and so on and so forth. Okay, so if I need, let's say I want to have a plus b to the 20th, then I need to basically build a very big Pascal triangle from 1, 1, 1, all the way to 1, 19, whatever, you know? So it will be a very, very big triangle if I need the degree of 21 or 22. I think even if it is degree of 10, I will not use Pascal triangle anymore. You know, I teach you how to build this Pascal triangle because in my opinion, it's actually a lot faster. It's a lot faster for smaller number. Okay, let's say up to 5 or 6. I think it's actually a lot faster to do it using Pascal triangle. Now, but when n is larger, then we will use other method. The second method is combination method. In our calculator, you will see that using notation NCR. But in our textbook, you will see we use this notation NR. Now, notice that when I write this NR here, it is without this line. No, it's not a fraction. It's not a fraction. Okay, it's without that line. It's without the fractional notation. Now, this NCR actually stands for n factorial over r factorial n minus r factorial. That's quite confusing, huh? Yeah. I will teach you the calculator first, then how to use calculator. I assume you use TI-30 or TI-36. How to use combination. First one by calculator. Suppose I have 12C5. Or our textbook, we write that as 12, 5 in that parentheses. Now, according to the formula we have above, you know what? I teach you calculator first, right? So according to calculator, this is what you will punch. You will punch 12 first. And then if your calculator have this option, you usually go to PRB. and then move your cursor to MCR. And then you press 5 and then enter. Please use your calculator. Most of the time, I think you will use calculator. Okay, most of the time you will use calculator. Now let me show you using my calculator, which is TI-84. Okay, now I know that you use TI-30 or TI-36. Make sure you know how to use your calculator. Okay. Okay, 12 combination 5. I press 12 first. Now on my calculator, it will be on Math, PRB, and then NCR. Now when you use TI-30, it will be simpler punch. You don't need to go to Math first. There must be a PRB. There must be a PRB button on your calculator. I get 792. Okay, so according to my calculator, 12 combination 5, or in our text, they write it as 12, 5 like this, that's 792. Okay, now can I ask you to confirm that you know how to punch it on your calculator? Let me ask you to do another one. Let's say if I ask you to do 14C2, our textbook, which is older notation, but mostly upper level math tend to use this parenthesis notation. Lower level math tend to use this C notation. Okay, I'm sorry. I think I got it wrong. Should be 14C2. Okay, let me ask you to use your calculator and then tell me what it is.
I got 91.
Yes, that is 91. Okay, good. It's 91. That's how we punch it using calculator. And I think that's what you will do if you use calculator. Okay. I mean, if I have a choice and I have calculator, I use calculator. Okay. But for some small numbers, you may prefer to use to do it by hand. But it don't. If I were you, I will not do that though. That's useful for if you are in much higher math. If you are in much higher math. But let me show you first how to do it by hand. Okay, part B, by hand. Now I show you by hand method if you have smaller number. Okay, first of all, what is n factorial? N factorial means n times n minus 1 times n minus 2 all the way down to 2 times 1. So for example, if I have 7 factorial, that will be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that's what it means. By the way, this you can also do this by calculator. By calculator, that will be you press 7, and then you go to PRB exclamation mark, and then you press enter for TI-30. Thomas, what happened if I use different calculator? Then you find out using different calculator. Okay, but usually you can find it out by going to YouTube, and then you type for example, suppose you use Casio series 1, 2, 3, 4. Then you type, you go to YouTube, and then you type Casio 1, 2, 3, 4 factorial. Casio 1, 2, 3, 4 combination. Okay, and hopefully somebody actually doing the video on how to punch those numbers in the the, the keystrokes for those. Okay, well, anyway, now then suppose I have earlier that 12 combination 5 according to our formula. That's 12 factorial over 5 factorial. 12 minus 5 is 7 factorial. Okay, which if I write it down, be patient with me. I know this is long, but doing it by hand give us some little shortcut, which is quite powerful and effective and efficient when the number is quite small. So 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1 over 5 factorial, 5, 4, 3, 2, 1 times 7 factorial, 7, 6, 5, 4, 3, 2, 1. Okay, so my 12 factorial, my 5 factorial is given here. My 7 factorial is given here. Okay. Now notice that the number on the top will always be larger because the number here, this number 12 here, has to be larger than the number on the right hand side. Okay, the number on the top here has to be larger than the number at the bottom. That's for combination to work. Okay, now then you will see that this part here always cancels. This part here always cancels. Such that 12 combination 5 can be seen as 12 combination 5 can be seen as starting from 12 and 5 factors on the top going down 12, 11, 10, 9, 8. Okay, and this 5 also the number you start at the bottom all the way down to 1. That's also 5 factors. That's the confusing. There's too many things to take care of. Okay, let me redo it then. Let me redo it. So when you ask me to compute 12 combination 5, I basically compute this. This 12 here is the number I start from the top. 12, 11, 10, 9, 8. How do I know I can start? I need 5 factors. I need 5 factors. So start from 12. So 1, 2, 3, 4, 5. Now how about the denominator? And you start from that 5. 5, 4, 3, 2, 1. That's what you multiply. Okay, so for example, I want to compute this further. Let me do canceling. Let's say this 10 cancel with 5, I get 2. Okay, and then this 12 here cancel 4 times 3. Oh, you know what? Let me cancel that 2 with this 2 also. Right, so I end up with 11 times 9 times 8. 9 times 8 is 72. 11 times 72. You add these two numbers, you get 9. Okay, now notice that this method will be quite useful if I had used this to compute 14C2. Why? Because 14C2 means start from 14, I just need 2 factors, and at the bottom I get 2 times 1. That's all. And I can cancel this, I get 7. So 7 times 13 is 91. So if you happen not to have your calculator handy, then manual method may be better. Okay, manual method is better in the sense that it's efficient and effective. Okay, but if you ask me 14 combination 5, I get my calculator. Okay, now that's what it is. So going back to the extension we have for that binomial theorem, you will see that a plus b to the 7, for example, we know that's a to the 7 plus 7 ab to the 6 plus what's that? After 7 is 2125. So that's 21a squared b to the 5th, 35a cubed b to the 4th, plus 35a to the 4th b cubed, plus 21a to the 5th b squared, plus 7a, my a, I think I write my a incorrectly. My exponents are supposed to be starting from 7 going down 48. My bad. So it should be a to the 6b, a to the 5th b squared, a to the 4th b cubed, a cubed b to the 4th, a squared b to the 5th, 7b to the b to the 6th, ab to the 6th, plus b to the 7. That's what we have earlier, right? Now then, how to get these coefficients? Now this one here, this invisible one here, comes from 7 combination 0. This 7 comes from 7 combination 1. This 21 coming from 7 combination 2, 7 combination 3, and so on and so forth, all the way to 7 combination 7. Okay, so for example, this 7 combination 3, if I do it by hand, 7 combination 3, that is 7 times 6 times 5, 3 factors, right? And then over 3 times 2 times 1. Now notice that 3 times 2 cancels with 6. So I get this is 7 times 5, which is 35. Okay. Now you will see, because of symmetry, remember the symmetry we talked about earlier? Then you will see that 7 combination 3 is the same to 7 combination 4. Now this combinations method thingy is actually quite interesting. Combination and another method called permutation, factorial, are things being heavily studied in discrete math. If you are going to computer science, then you need to deal with this a lot. Okay. By symmetry, you see 7 combination 3 is equal to 7 combination 4. As long as they add up to the same number, 3 plus 4 equals to 7. Yeah. Right? Okay. Now Now you will also see 7 combination 2 is the same to 7 combination 5. Why? Because 2 plus 5 is equals to 7. Okay, that's the phenomena we see from the symmetry that we saw earlier. Now, let me ask you to apply what we have done so far to this. A plus B, let's say to the power of 10. Okay, now first you can write the pattern first, A to the 10, and then 10, A to the 9B. We know the first and second terms, right? Okay, and then all the way down, A, all the way. I hope you know how many terms we're supposed to have. And the last one be 10. Okay, now I would like you to find out the full expansion of this A plus B to the 10. You know the first two terms, the coefficient for the first two terms, and therefore you know the coefficient for the last two terms too. So this will be 10AB to the 9. But I need you to find the rest. Let me give you 2 or 3 minutes for this. Okay, I need you to be super good with this. Okay, let me give you 2 or 3 minutes. I'm sorry. Yeah. Uh, I'm sorry. But I hope even without my voice, you can understand. Any questions so far? My bad. Now, let me go on here. The same pattern. This is 10 combination 4. Okay. Now the 10 come from the exponent 10. And the 4 here comes from the exponent of b, the exponent of the second variable. Okay, even though you know that if you do 10 combination 6, you will get the same thing. Okay, now then what is 10 combination 4? I think the number is quite big already. You may prefer to use calculator, but if you still insist to use by hand, let's take a look. That's 4, 3, 2, 1. 8 cancels with 4 times 2. 3 cancels with 9 cancels with 3. Then I get 110. So this is 210 also by symmetry. Okay, I still have this term missing the coefficients. So what is a to the 5th, b to the 5th? What's the coefficient? Then it will be 10 combination 5, which is 10 times 9, 8, 7, 6 over 5, 4, 3, 2, 1. 10 cancels with 5 and 2. I guess 8 cancels with 4. 9 cancels with 3. So 3 times 2 times 7 times 6. 3 times 2 times 7 times 6. I think it's harder to do right now, huh? 6 times 6 is 36 times 7, 21, 152. Yeah, but I think it's I rather use calculator because it's easier for me and more accurate, of course. It's easier and faster, more efficient using calculator. So small numbers, you do it by hand. Maybe bigger number, you use calculator. Okay, now let me erase all these here so that it doesn't really distract us, like get too overwhelmed. So you see that students who don't follow my live lecture, they will be missing this. They will only see my note, and if they watch the lecture video that I record, they may learn something, but very likely they miss what the hand method, the manual method. Okay. So we have now known how to do expansion for a plus b to n power. Okay. Should I ask you to do one more example? Just to make sure, but this time you do it from the very beginning. Okay, let me ask you to do, let's say x plus y, x plus y, take it to the power of 8. Yeah, I want you to do it too from the very beginning. I give you 3 or 4 minutes for this. And this will be x to the 8 plus 8x to the 7y plus, I think 8 and 4, 7, 28 x to the 6y squared plus, I don't know, x to the 5th y cubed plus, I don't know, x to the 4th y to the 4th plus x, I don't know, x cubed y to the 5th plus, I don't know, x squared y to the 6th plus, I don't know, x y to the 7 plus y to the 8. And then I look back, oh, you know what? I actually know this. What is this? By symmetry, that's 8, that's right. And likewise, by symmetry, this is 28. Okay. How do you get that 28 earlier, Thomas? Well, that's 8 times 7 over 1 times 2, right? That's 4 times 7, that's 28. Correct? Okay. Now then, how about this guy here? That's 8 combination 3. So 8 combination 3, that's 8 times 7 times 6 over 1, 2, 3. Oh, that's 56. Okay, and that's 56 here, 56 here. Oh, not that bad, huh? Okay, and then lastly, a combination 4. That's 8 times 7 times 6 times 5 over 4, 3, 2, 1. 6 cancels this way, this cancels this way, so that's 70. Oh, okay, do you get the same thing? I hope so. Okay, now implicitly, you already did some substitution instead of dealing with A and B. Now you already substitute the A by X and the Y by the B by Y. Now you will see for the remaining of this section is actually substitution. Okay, so for example, what happens if I have x minus y to the 6, for example? We will see this as x plus negative y to the 6. That's how we will see it. Okay, that's how we will see it. And then the expansion will be x to the 6 plus 6 times x to the 5th negative y to the 1 plus 6 choose 2, that's 15. 15 x to the 4 negative y squared plus 6 choose 3, 20 x cubed negative y cubed, and then 15 x squared negative y to the 4 plus 6x negative y to the 5th plus y negative y to the 6. So I replace the b instead of a plus b. Let me put it this way: a plus b. Okay, I see that as a plus b, like that. Okay, so then I play with that a. In this case, this is the b, this is the a. Okay, now anything after that is further computation. Simplifications is x to the 6 minus 6x to the 5th y plus 15 x to the 4 y squared plus, let me confirm, is it really 6 combination 3 is 20? 6 combination 3, yeah, that's 20. So this is, should be minus here. That would be minus 20x cubed y cubed plus 15x squared y to the 4 minus 6x y to the 5th plus y to the 6. Okay, so basically the first thing I do, if I see something different from a plus b to the n, I will see that in the pattern of a plus b to the n. Okay, now suppose I do problems from our book now. Now we can go back to the book and do problems from the book. So problem from the book, for example, number 20. We have x squared plus 2y cubed. This is my A. This is my B. Okay, and then it will be A cubed plus, well, it's to the power of 3. I think that's easy. The power of 3, the expansion is 1, 3, 3, 1. That's the expansion. Okay, let me just go ahead. So this will be 3x squared times 2y to the 1. You see? A cubed, a squared, b, oops, a squared b, okay, and then plus 3a to the 1b squared plus b cubed. Then anything from there will be just simplification. Okay, there will be x to the 6 plus 6x to the 4th y plus 3 times 4, that's 12, x squared y squared plus 8y cubed. I would like you to try number 26. Number 26, do the expansion for 1/2 x plus y cubed to the 4. To help you with the coefficients, you can look at the Pascal triangle there though, okay? You can look at the Pascal triangle, that's 1, 4, 6, 4, 1. Okay, and then play with the A and B thingy. Okay, maybe 2-3 minutes. Okay, let me start working on that too. This would be 1/2 to the 4th is 1/16 x to the 4th plus this is 1/2 x cubed y cubed plus 3x squared y to the 6 plus 2xy to the 9th plus y to the 4th. Okay, right?
Thomas, I have a question.
Uh-huh.
On number 26 in the book is 2t minus s.
I look at number 28. My bad.
No, that's okay. But like if we were doing like an x minus y, but I guess my question is, since it's t minus s,
2t minus s.
when it's 2t minus s,
Mm-hmm.
do you want us to write t first and then s? Because I know usually it's like
No, we just
alphabetical.
look at it right away this way. This is our A, and this is our B.
I know, but once we once we reduce it, since s comes before t in like the alphabet, aren't you supposed to have s before t?
Oh, on the final answer, yes. But I will
On
not
the
worry about that though. At this point, I will not worry about that. And what you said about that alphabetical order, T S thingy, okay, that's just that's not something I can fully enforce. In other words, I cannot mark somebody off for writing b cubed a squared, for example. No, I cannot mark somebody off. I would love to, but I cannot.
Okay.
Yeah, I cannot. Yeah. Okay.
Okay,
Yeah.
thank
So,
you.
but thanks for asking that. Good thing is no need. Okay. Now let me do this then. Sorry. The fifth expansion, as I remember, is 1, 5 for sure, and then if I choose 2, that's 10. Is it right? 5 combination 2.
Yeah, it's 1, 5, 10, 10, 5, 1.
Oh, thank you. So this will then be 2t to the 5th plus 5 times 2t to the 4th negative s plus 10 2t cubed negative s squared plus 10 2t squared negative s cubed, and then plus 5 2t negative s squared 4 to the 4th, I'm sorry, and then plus negative s to the 5th. Now, actually, you will see one pattern. Another one pattern is if it is subtraction instead of addition. If it is subtraction here, if that's subtraction there, then we will have the terms are alternating positive, negative, positive, negative. Okay, so if I make it nicer here, this will be 32t to the 5th minus 16 times 5, 80. So 80t to the 4th s plus 8 times 10, that's another 80, huh? Minus 4 negative 40t squared s cubed. And then that's plus 10 t s to the 4th minus s to the 5th. Is it right? Okay, nobody say anything. I look at my book. I happen to have instructor's edition, so yeah, that's the right.
That's what I got. Yeah, that's what I got.
Yeah. Okay. It gets more complicated though. It gets more complicated, but we basically have this situation here. Remember the pattern. Okay, remember the pattern. Always, I strongly suggest you always do this first. Always do this first. Okay, before you simplify. Always do this first. If you happen to do what I wrote earlier with my wrong number, always do this first and then simplify. Okay, don't rush to the answer though. Don't rush to the answer. Okay, the most elegant method is not the same to the best method when it comes to your level because of the following. When you take a test, what the main problem with a lot of you and me when I took my test too is we have restricted time. Okay, so the shorter step does not imply the best method. No, simply because you write less doesn't mean it's the best, because it is possible you write less, but for each step it takes you a long time to think. It's better for you to write more, but each line that you write, whatever you write, is something you can write comfortably at a nice speed, and at the same time you still maintain your confidence. Okay, what you don't want to do is like you skip all the steps and then at the end of your work you don't have confidence in what you do and you erase that again. Okay, now that explains why we prefer to take freeway when there's no traffic. Right? Freeway always give you longer distance compared to local. But why we take freeway anyway? Because, well, freeway give you less time even though further distance, right? Okay, now we apply the same idea for working on your test. Okay, now let's go on to the next example before I go crazy. What I mean is this one, number 32. If I have square root of x plus 1 over square root of x to the 5th. Now you can see this as x to the 1/2 plus x to the negative 1/2 to the 5th. Okay, let me give you 2 minutes to do this. I know in 2 minutes you may not done yet, but may not be done yet, but at least you get the idea already in 2 minutes. Work it out. this will be x to the power of 1/2 to the 5th plus 5 x to the 1/2 to the 4th x to the negative 1/2 plus 10 x to the 1/2 cubed x to the negative 1/2 squared plus 10 x to the 1/2 squared x to the negative 1/2 cubed plus 5 x to the 1/2 x to the negative 1/2 to the 4th plus x to the negative 1/2 to the 5th. Okay, simplify further. This is x to the 5/2 plus 5x to the 3/2, is right? Plus 10x to the 1/2 plus 10 to the negative 1/2 plus 5 to x, I'm sorry, 10x to the negative 1/2, 5x to the power of negative 3/2 plus x to the power of negative 5/2. Okay, go on. How about the next thing will be quite fast. Okay, the next couple of things will be quite fast. I assume you already get the idea already. So number 34, for example, the first two terms of 2x to the 4th plus 3x to the negative 2, all of them to the 6th. Just the first two terms. So the first term will be 2x to the 4th to the
6.
6 plus, what is the coefficient? Next one.
6.
And then 2x to the 4th to the 5th, 3x to the negative 2. Okay, that's the first two terms. Now 2 to the 6 is 64 plus this is 6 times 32 times 3, x to the 20th, x to the negative 2, and on. This will be 64 x to the 24th. 32 times 18 is what? 32 times 18 is 576 x to the 18. I hope you get it. I don't want you to get distracted with the computation. I want you to pay attention to the pattern. Okay, it's a plus b, right? So it will be a to the 6th, a to the 5th, b. That's the first two terms. Okay, now then with the coefficient that's 1, 6. Remember? Okay, get those first. And then whatever coming after that, just simplification. Okay, now do not do the expansion and simplification at the same time. I have not seen anybody can do that in appropriate time. Okay? I have seen people who can do that just in one single step, but they take too much time. No need. Okay, at the end, when I grade your test, it's about do you get it right or not, and do you show proper work or not, right? It's not about, you know what, I do it in only one step and I'm better than you because you do it in 3 steps. No, doesn't matter. Okay, in fact, if you do it in 1 step, I may question how you get that, right? Okay, so show your work, trust me. Okay, number 36. Number 36. x cubed plus 5x to the negative 2 to the power of 20, and we need 3 terms. First 3 terms. First 3 terms. So it will be x cubed to the power of 20 plus 20 x cubed to the power of 19, 5x to the negative 2, plus the third term will be 20, choose 2. 10 times 19, 190, x cubed to the power of 18, 5x to the negative 2 squared, plus dot dot dot. Now the first term is x to the 60 plus 100 x to the 57, x to the negative 2. You know what? Let me just see. Plus 190 times 25, x to the 54, x to the negative 4. One more step. The first term is already fixed, x to the 60. The second term, I just combine the x's. So 100x to the 53 plus 19 times 25, 475 with extra 0, x to the 50, and on. Number 38. What happens if they ask the last terms instead? Number 38. The last 3 terms. Last 3 terms of s minus 2t cubed to the 12. So I will do it from the last terms instead, okay? But I still write it in correct order. So this thing, the last term is here, right? So that's negative 2t cubed to the 12, right? And then s negative 2t cubed to the 11, s squared negative 2t cubed to the 10. The coefficient will be invisible 1, 12, and then this guy here will be 12 choose 2, 12 choose 2 will be 66. Okay, so this is blah 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 equals to 66 s squared times 2 to the 10, 1024 t to the 30th plus 12 s times negative 2024, 48, I'm sorry, 2048 t to the 33rd plus times another 2. So that will be 4096 t to the 36. This is equal to, let me use my calculator, 66 times 1024, 67,584 s squared t to the 30th minus 2048 times 12, 24,576 s t to the 33rd plus 4096 t to the 36. A bit more, maybe two more questions. For example, number 46, maybe one more. Okay, number 46. Number 46 is a question that is shorter but a bit harder. X squared minus 2y cubed to the fifth. And we want the term containing, we want the term that contains y to the sixth. Now to have y to the sixth, to have y to the sixth by induction, we know we must have negative 2y cubed squared. Is that right? That's the only way to have y to the sixth. But for that to happen, I must have x squared to the power of 3 negative 2y cubed squared. Why? Because the exponent has to be total of 5. Okay? And then furthermore, therefore, the coefficient will be 5 combination 2 x squared cubed negative 2y cubed squared. Now, that's what we will simplify. 5 combination 2, I believe, is 10. X to the 6 times 4y to the 6. So that's 40 x to the 6 y to the 6. Okay, your suggested homework from here, that's 9.5. Question number, I think I will ask you to do every other odd from number 1 to 31, every other odd. Of course, you can do more, but then from 33 to number 47, do the odd ones. Okay, I want you to do more for this. Okay, we will take a 10 minutes break. Let's come back at 11:12. Okay, let's start again. Now I jump back to 9.1. That is the introduction to sequence and series. I will not cover the whole 9.1 today. And what I do right now for today, it's more about understanding notation. And of course, there will be some computation, but it's more about understanding notation. Okay, then on Wednesday, we will do the computation, which is actually on the easier side. Intro to sequence and series. What is a sequence? A sequence is an ordered list of numbers. The keyword is with the word order. So the order is important. Now, for example, we have this sequence, the sequence of 5, 8, 11, 14, 17, and on. Now, if I use ellipsis like this, it means it goes infinitely more, okay, indefinitely far. notation, the first term is usually denoted by a subscript 1. The second term denoted by a subscript 2. The third term denoted by a subscript 3 and on. Of course, we don't need to use A all the time. We can use B subscript 1 or C subscript 1 and so on and so forth. Okay, the emphasis is on the indexing. Okay, so in this case, if I ask further, can you tell what is the sixth term? Anybody can tell?
20.
20, that's right. Okay, because from here you see a pattern that to the next term, I keep on adding 3, right? I add 3, I add 3, I add 3, on. Now, that's an example of a sequence. Now, there are 3 methods of, at least the one we see in this textbook. There are 3 methods to represent a sequence, to represent sequence. I said it almost wrong earlier. I said that there are 3 methods. I was about to say there are 3 methods to represent a sequence. That's not a really nice way to say it. Some sequences better done in one method than the other one. Okay, there are some sequences you cannot do one of these methods. Okay, but let me describe first what are these 3 methods. The first method is by listing. That's basically what I did earlier. I provide you the list. In your example 1, I give you the list. Now, don't forget, in a sequence, order is important. So what you start and the next term, the next term, the next term is important. Do not change the order. Okay? Listing method always work. Listing method always work. Now, the second method is by general term. Or sometimes we call that by formula. For example, I say a sub n equals to 3n plus 2. So I give you the formula instead, and you see this as a function. Okay, when n equals to 1, so for n equals to 1, that would be 3 times 1 plus 2, that's 5. When n equals to 2, that's 3 times 2 plus 2, that's 8. The third term, you replace the n by 3, that's 11, and on. Okay, that's by general term or by formula. Now, this may also be written using another type of notation. Okay, we may write it this way. Okay, now when you see a formula in n, in terms of n being in between this, this bracket here, then that's just another way to write general term by formula. Okay. The third method is called by recursive. By recursive form. Recursive form. Now, for example, I give you the first term first. The first term is 5. And then the next term is equal to the previous term, let's say plus 3. So recursive form is for a sequence is given by a formula in which for us to get the next term, we need to get the previous term. Okay? To get the next term, we need to use the previous term. So using this recursively, then we see the first term is 5. The second term, which is a sub 1 plus 1, right? Means the n equals to 1 is a sub 1 plus 3. That's 5 plus 3. Basically, the second term is the first term plus 3. The third term is the second term plus 3. But the second term is something we get earlier. And then the fourth term is the third term plus 3. And so on and so forth. Now, that's what we mean by recursive. So for recursive form, we see the pattern. You keep on adding 3 in this case. Not always, though. Not always like this, though. But we see the pattern, how to get the next term. But we cannot jump right away to, for example, the 100th term. For us to get the 100th term, we need to get the 99th term. And for us to get the 99th term, we need to get the 98th term, and so on and so forth. So basically, for me to get, let's say, the 100 terms, I need to get all the previous terms before I can tell what is the 100th term. Okay? So that's the weakness of recursive form. Okay? But recursive form is actually better done using computer. If you have computer, then a lot of program is being done in recursive form. Now, on the other hand, general term, we use formula. I can get the 100 term right away without knowing what is the 99th or 98th term. Okay, like for example here, the 100 term will be 302, correct? Okay, but using recursive form, I need to get the 5th term, the 6th terms, all the way to 99th term before I get the 100 term. Okay, so recursive form gives us how we get the current term using the previous term. The general term, or the by formula, doesn't tell us the behavior, but it gives us the formula how to get that particular term right away. Okay, by listing, is basically give us what are those first couple numbers. Okay, now those are just for notation examples. For example, I do number 2. The question is find the first 4 terms. For, you know what? Let's apply that to number 2. Number 2, the sequence is 3 over 5 and minus 2. Then this will give us, the first term is 3 over 5 minus 2, right? Which is 3 over 3, which is 1. The second term is 3 over 10 minus 2, 3 over 15 minus 2, 3 over 20 minus 2. Let me complete that. That's 3 over 3, that's 1. This is 3 over 8. This is 3 over 13. This is 3 over 18, which is 1 over 6. And then how about the eighth term? A sub 8 will be 3 over 5 times 8 over minus 2, which is 3 over 38. Okay, I hope you find it to be simple enough. As for number 2, how about number 10? Number 10, we have this sequence, -1 to the n, 6 minus 2n over square root of n plus 1. We just need the first 4 terms. Now you will see this guy here doesn't change the value except the sign, the plus minus, plus minus, plus minus. And because of that, when n equals to 1, that will be negative, right? When n equals to 1, 6 minus 2 over square root of 2. When n equals to 2, I get positive 1. 6 minus 4 over square root of 3. When n equals to 3, that will be minus 6 minus 6 over square root of 4. And the fourth term will be positive 6 minus 8 over square root of 5. Which, if I simplify, I get this is negative 4 over radical 2, 2 over radical 3. This is 0, negative 2 over radical 5. I think I can simplify further, rationalize the denominator. So this is negative 2 radical 2. This is 2 radical 3 over 3. 0, negative 2 radical 5 over 5. Okay, that's for number 10. Now, how about recursive method? Let's say number 22. Number 22. Again, I will just do the first 4 terms or 5 terms. Okay, a sub 1 equals to 5. A sub k plus 1 means the next term after the k term is 7 minus 2 times the k term. Okay, so the first term is 5. The second term will be 7 minus 2 times the first term. Okay, now then the third term will be using that formula again, 7 minus 2 times the previous term is 7 minus 2 times negative 3. 7 plus 6, that's 13. And the fourth term, 7 minus 2 times the previous term. 7 minus 6, that's negative 19. And the fifth term, 7 minus twice the previous term. So 7 plus 38, that's 45. Okay, so the sequence will basically be 5, negative 3, 13, negative 19, 45. And on. Can you try number 26? Number 26. The first term is 3. The next term is 1 over the previous term. Okay, let me give you 1 minute. This happens to be an easy question. So you see this sequence basically 3, 1/3, 3, 1/3, 3, 1/3. Is it right? I hope up to now you still see this is just notation. No thinking yet, seriously, no thinking, except rationalizing the denominator, right? Adding, subtracting, multiplying, come on, that's, I don't think you need to think hard for that, okay? You just need to know the notation for now. Now, those are for sequence. How about series? Let me first introduce you to the summation notation. Summation notation sigma. The way you write your sigma should be done in the following way. The top line first, and then the middle inequality sign, if you want to call that, and then the lower line. Okay, that's what a summation notation should look like. Not like this, not like this, not like this, not this, no, no, not this, not this. This one is okay, actually. Okay, it's basically like a capital M that you turn 90 degrees to the left. Okay, it looks like capital M that you turn 90 degrees to the left, counterclockwise. Okay, that's the summation notation. Now then, indexing. The number at the bottom here, the variable n will be the indexing, and the number at the bottom is the number you start with. The number on the top is the number you end with. Okay, so this number here means starts from n equals to 1 up to n equals to 4. Okay, so for example, if I have the summation n equals to 1 up to 4 of 3n plus 2, then I will do the summation for when n equals to 1, n equals to 2, n equals to 3, n equals to 4. When n equals to 1, I get 3 times 1 plus 2. That's the first term. Plus 3 times 2 plus 2. That's the second term. Notice that I use this pattern again. I use this pattern when n equals to 1. This pattern when n equals to 2. Okay, plus 3 times 3 plus 2. plus 3 times 4 plus 2. So I apply the same pattern 3n plus 2, but the n here is moving from n equals to 1 up to n equals to 4. Okay? Then computing it, that will be 5 plus 8 plus 11 plus 14. That's 38. Okay. Now, I will not teach you any formula yet. I think if I do, that will be on Wednesday. But for now, I really need you to understand what this notation means first. Okay? What this notation means first. Suppose another example. Let's do another example. Another example, suppose I have the summation k equals to 3 up to 7 of 2 to the k plus 1. So if I have that summation, I start with k equals to
3,
3 up to k equals to
7.
7. So basically later on I have my k equals to 3 plus when k equals to 4, k equals to 5, k equals to 6, k equals to 7. Okay, now then when k equals to 3, this would be 2 to the 4th, right? Plus 2 to the 5th, plus 2 to the 6th, plus 2 to the 7th, plus 2 to the 8th. Okay, which will give us 16 plus 32 plus 64 plus 128 plus 256. Now, I don't know what's that, but I can use my calculator. I get 496. Let me check again, just in case I found something wrong. Yeah, 496. Is it okay? Now, but be careful though that in the indexing may be quite confusing. You need to pay attention to details. Suppose I have n equals to 4 up to 10, and the sequence that I need to add is, let's say, 3 to the k plus 2. So I need to add when n equals to 4, n equals to 5, n equals to 6, n equals to 7, n equals to 8, n equals to 9, n equals to 10. Is that right? Now, then when n equals to 4, what will this be? What will this be when n equals to 4?
3 to the 6.
No. 3 to the k plus 2.
Okay.
Notice that the index is n, not k. Right? The index is n, not k. So this k here is not the same with the index in here. You see? It's not the same. So the n is moving, n equals to 4, n equals to 5, n equals to 6, and on. But the one, the variable you use in this sequence here, you don't use n here, you use k. So if you run this on your computer and you happen to define different variable, then this will be 3 to the k plus 2 plus 3 to the k plus 2 plus 3 to the k plus 2, so on and so forth. You see what I mean? Which will give us, if I combine that, what do I get? How many terms there, by the way?
Seven.
7 terms, not 6 terms. The reason I ask you, make you think and make you see is this. It's clearly there are 7 terms here, okay, after I write them down. But some people try to do a shortcut, which is happen to be incorrect interpretation. Some people subtract this, 10 minus 4, that's equals to 6, and then say there are 6 terms. No, there are 7 terms. But Thomas, 10 minus 4 is 6, that's right. 10 minus 4 is 6, means there are 6 numbers after 4. There are 6 numbers after 4. These are the 6 numbers after 4. Not including 4 itself. But this summation starts from 4, not starting from the number after 4. Okay, so when you do subtraction, don't forget to add 1. Okay, so there are 7 terms, not 6 terms, which then, if I combine them, I will get 7 times 3 to the k plus 2. Okay, maybe I emphasize that again, not 6. Now that gives us the idea for question like number, let's see, there are some problems in our textbook require us to use formula though, which they provide in the book, but I don't teach you any formula yet. Suppose, for example, question number 48. The summation of, for k equals to 1 to 1000, how many terms here? From 1 to 1000?
1,000.
1000 terms, the summation of 5. Now notice that we are basically adding 5 for the first term. What is the second term?
5.
Another 5. How many times do I need to add this?
1,000 times.
1000 times, that's right. (1,000) constant terms, that will give us 5,000, 1,000 times that constant. Now, let's use this for question number 50. So question number 50 is actually quite similar. Number 50, the summation for k equals to 137 up to 428 of 2.1. Now, can you tell me what's that? How many terms first?
$292.
How do you get that?
428 minus 137 plus 1.
Okay, that's 292, you say?
292.
Okay, so the sum here will be 292 times 2.1, right? I get 613.2. Okay, now I'm basically done with the main material that I want to do today. Now let's do one formula then. Memorize one formula. Okay, memorize one formula. Maybe I write this first. Formulas. The summation from k equals to 1 to n of a constant, let me call that constant, I'm sorry, let me call that constant c. That will be c times n, because they are n terms. Each term is c. Okay, in fact, if I generalize this, suppose my summation actually start from m up to n of the constant, then it will be, let's see how many terms first. There will be n minus m plus 1 terms. Each term is c. So this will give us c times n minus m plus 1. Okay, now other formulas. The summation of a sub k plus b sub k. So we have the summation of two terms from 1 to n. That's equals to the summation for each term. The sum for the the eighth terms plus the summation for the bth terms. Actually, that applies also for subtraction. So that's subtraction there, that's subtraction here. Okay, and then the summation for a constant multiple of a sequence, that will be equal to c times that series, the summation. Okay. So for example, if I have just how to use this, okay, just how to use this. For example, suppose I have a number 52. the summation from k, I'm sorry, from yeah, k equals to 0 to 5 of 3k plus 2. I modified the question a little bit. So this is k here, this is k here. Now I can see this. I can just do it one by one actually, the way we did earlier, right? Okay, the way we did earlier, I can do it one by one. So the first method you can do 3 times 0 plus 2. That's when k equals to 0, right? Plus 3 times 1 plus 2 plus 3 times 2 plus 2 all the way to 3 times 5 plus 2. I can do that. Okay, now another method is I rewrite it. The second method, I do it this way. Oh, this is the summation from k equals to 0 to 5 of 3k plus the summation from k equals to 0 to 5 of 2. Yes, the original question is j. I change it to k first. Yeah, I change it to k first. After this, I will show you what happened if that's j, which is actually simpler. Okay, which is actually simpler. Now, then from here, this is equal to 3 times the summation k here plus, now notice that there are 6 terms here, each of them constant 2. So this is 3 times 0 plus 1 plus 2 plus 3 plus 4 plus 5. This is 3 times 12, 16, 3 times 16 plus 12, that's 48 plus 12, that's 60. Now the original question is supposed to be j. So summation of k equals to 0 to 5 of 3j plus 2. Now notice that the index is k, but the variable here is not k. So then it means you need to see this because no variable k, right? No index in k. So you need to see this yellow one here as a constant term. Okay, you see that then as a constant term. That will be, if I write it long way, that would be that the 0 term will be 3j plus 2. The first term will be 3j plus 2. The second term will be 3j plus 2. Where this is when k equals to 0, this is when k equals to 1, and k equals to 2, all the way to k equals to 5, right? But how many terms there? Each one of them constant. There are 6 terms, right? So this will be 6 times 3j plus 2, which is 18j plus 12. Okay, so yes, it is different if the variable here different from the index here. For the counter to work, the index has to be the same to the variable you use, like what we had earlier. Okay, what we have up here, the index is k and the variable is also k. Then that variable k will start from 0 to up to 5, right? Okay, But then if the variable here is different from the index k, then you don't substitute the variable. I mean, you only substitute the variable if that's equals to the index. Is it okay? Now, this is where I will stop. Your suggested homework here will be for this 9.1 will be number 1 to 51. Just do every other odd and skip the graphing. So you can skip number 17 and number 19. Okay. Now then on Wednesday, the last day of our class, we will do 9.2, 9.3, which are, in my opinion, on the easy side. On the easy side, and if I were you, I will watch the lecture video from my other Precalculus class. Yeah, you can read the book also. I mean, that's okay, but sometimes our textbook give you too much details at once. So instead of giving you too much details, I want you to see the big picture first. Okay, so I think if you look at my other Precalculus class, that will be my Math 260 lecture video. Math 260, that will be section 13.3 and I'm sorry, 13.4 and 13.5. And yes, that will be the last sections. For us, it will be 9.2, 9.3. That will be the last two sections I cover for this semester. Okay, there are some materials I didn't cover though. There are some material I didn't cover, but I will help you. I will tell you where to study for those material that I didn't cover. The good thing is those that I don't cover, the polar and parametric equations. You will not see them in Calculus 1. You will see them in Calculus 2. Okay, so you have some time to actually catch up. Okay, but I still recommend you to watch them. Okay, that's for today. See you then on Wednesday.
Thanks, Tom.